Okay, hello, Math 8. This is going to be a little bit of an explanation about how to look at situations that may or may not be proportional, how to understand if they are proportional, and then how to use that information to make a table and a graph to represent the situation. And we'll be doing a lot of this over the course of the year, so this is just to start getting used to it. But the whole idea of the rate of change, how something's changing either at a constant rate or a changing rate, is a big theme of this class. So to explain this, I'm going to use question 41 from your CPM book in the section. And you can see I've circled what the directions say, which is to make a table and graph to represent situation A, B, and C below. And then we'll answer some questions about those on D. Now, I've written two important things about a proportion. So in order for it to be a proportion, which we're going to answer right here in D, it needs to start at the origin, meaning 0, 0, whatever the data might be, and then it's always going to change at the same rate, which means it's going to be a line, straight line, linear graph. So I've put the questions on the next slides so I can show the work. So the first question is Parvin cleaning dishes for her mother, and she cleans 17 plates in 10 minutes. How many plates can she clean in different amounts of time? Well, it's always nice to start with a table. Time is always x. So we will say that this is x minutes, and this is y plates. And we're given 17 plates in 10 minutes. So I'm just going to put that on the table because I wanted to leave room up top for some other values. And so the question that we have to ask is, okay, well, we're only giving 1 point, but it makes logical sense that if Parvin has been cleaning dishes for 0 minutes, that she would have cleaned zero plates. So that is something you're going to have to sort of logic into the problem. And going back to my slide from before, that kind of gives us a clue that it's starting at 0, 0. The other assumption that we're going to make is, and this wouldn't necessarily be true, but we'll have to make it, is that Parvin will be cleaning at the same rate. Meaning, if it takes 10 minutes to clean 17 plates, if you go another 10 minutes to 20 minutes, let's say, you're going to clean another 17 plates. So that would be 34. You could do that forever. You could go 30. Add 17. Ooh, I'm going to mess this up in my head. I'm going to say 51. You need to double check me at home. And so what we have here is a increasing at a constant rate. So we can make a graph. I only need the positive quadrant. And here's time. And here's plates. We want to make sure the scale makes sense. So 10, 20, 30, 40. Label it so that you know and I know what you're talking about in terms of what they mean. Plates, 10, 20, 30, 40, 50. And then we can just graph it. Here's our starting point. It goes up 10, 17, 20 is 34, 30 is 51. And what you see here is, if you're at all careful in your graphing, you'll end up with something that is a straight line. And that, again, is because we assume that it's at a constant rate, meaning it's going to be changing at the same rate each time. Okay, that's A. B. Yasmin's puppy Maggie weighed 14 ounces at birth. She doubled her birth weight every 10 days. Assuming her growth is constant, when you hear that, you think line, straight linear line. How much will she weigh at various times of the first year? Well, we can start with the table. This is X days. This is Y ounces. And what we're told is that she weighs 14 ounces at birth. Well, birth is 0 days, and there's 14 ounces. And remember our rules for proportion. It's not looking like this is going to be a proportion because it doesn't look like it's going to go through the origin. But more on that later. Okay. Now she doubled her birth weight in 10 days. So at 10 days, she She went to 28. Now, growth in constant means not necessarily that it's going to double every 10 days, but that it's a constant rate. So in order to think about that, we want to think about the unit rate. So going from 14 to 28, she increased, or the puppy increased by 14 ounces. And that increase happened in 10 days. So the rate, if we want to look at it as ounces per day, is 14 ounces in 10 days. Well, that unit rate means that we divide that. Hopefully you remember that. 14 divided by 10, you move the decimal place 1 to the left, so we get 1.4 ounces per day, which is also the same as 14 ounces every 10 days. So if we want to go up by another 10 days to 20, then we can go up by another 14 ounces. 28, 38, 42. And we can go another 10 days and another 14 ounces. And so on. So there are some different weights. We could go higher up in the year, but that's a good start. Again, we have days, and we need to go 10, 20, 30, and so forth. And on our ounces, 10, 20, 30, 40, 50, 60. And here we have 0, but it starts at 14. So it's not going to start at the origin. It's going to start up higher on the y-axis. Then here's our growth rate of, after 10 days, 28. After 20 days, 42. And, oops. If I'm doing it right, and again, these are a little bit freehand, so they're not going to be perfect, but we want to make them as good as possible. It should appear to be going in a line, and it does. It's not perfect, but that's not because the numbers are right, or maybe they are wrong. You can check my math, but it's because I'm graphing on non-graph paper. Okay, so there's the chart and the graph for this one. Next situation. C, Angel saw an internet pop-up advertisement for an investment that doubles your money every year. Just a little side advice. If you see that internet investment pop-up, don't invest in it. It's probably too good to be true. So Angel invests $20 her grandmother gave her for her birthday. So we're talking about money and years. So our variables are, remember, time is always the x value, x years, and y dollars. So she starts before with $20, and that's before any time has passed. So her 0 years, she has $20. After 1 year, it doubles. Now here, after 2 years, if it doubles every year, that's not increasing at a constant rate. It's doubling, which is different, you'll see. So after 2 years, it's going to be 80. So you see here it increased by 20, and here it increased by 40. So it's not changing at a constant rate, but it's doubling, which is a different thing. This would be what we call exponential growth. So here we have 160. You see the numbers getting big very fast, and so forth. So I'm going to make a graph that shows years. 1, 2, 3, 4. We'll go by hundreds. $100, $200, $300, $400. And so at 0, there's her starting investment, $20. At 1 year, it's gone up to $40. At 2 years, still under 100. 3 years, now it's gone up to $160. 4 years, it's gone up to $320. And what you see is, and you've probably seen this before, it's not increasing at a linear rate. It's actually going up like this. Okay, so the question that we need to answer for each of these was, is it proportional, and how do you know? So this first one, is it proportional? Yes. because it goes through 0, 0. That's there. And it increases at a constant rate. So it's proportional. The next one, is it proportional? Well, it is linear, but we can't say that it's proportional because it doesn't start at 0, 0. But it is linear, meaning it increases at a constant rate. So this is a linear example, but it's not a proportional example. And then finally, is this one proportional? Well, no, for two reasons. It doesn't start at 0, 0, and it isn't even linear growth. So this is the kind of understanding that you're going to be applying to your CPM work today. Sorry for the longer video. I hope you, what you should do is if you get confused on the next questions you're working on, you should go back and like fast forward this video to the relevant parts and replay it. Don't forget to smash the subscribe button on the YouTube channel. Share it with all your friends. Let's make this thing go viral.